All right, today we're looking at how to turn word equations in sentence form, like you see here in front of you, into a much shorter formula equation. If we had to write out all of our equations this way, this takes a lot of time. And in chemistry, you know, we try to shorten up things as much as possible. So we are going to try to turn all of this into our chemical formulas and symbols to try to shorten these things down, make it nice and quick and easy to write down and to get information from. So what we're interested in is finding all the chemicals in our equation. In this case, methane plus oxygen yields carbon dioxide and water. We're interested in turning methane, oxygen, carbon dioxide, and water into formulas. I would imagine a couple of these you know already pretty easily. Methane we haven't gone over yet. It's an organic compound, so we'll need some help with that one. And this is going to be the one that's going to give you trouble, okay, is oxygen. Everybody thinks they know oxygen. Nice simple element off the periodic table, but there is something special about it. So the first thing we're going to do is we're going to turn these into formulas. So carbon dioxide, this is what we learned last chapter. Notice that we do have a prefix there, so this is going to be turned into, this obviously has to be a covalently bonded substance. So these prefixes tell us exactly how many to use. So carbon is C, oxide is O, the die tells us that we have to do 2. So for carbon dioxide we have CO2, much shorter, much more compact, much easier. Water, everybody and their dog knows water. So we know water is H2O. Methane, this is one I'm going to have to give you. We don't know this one yet. Stick around for advanced chemistry. We'll learn all about methane. But methane is going to be CH4. It's actually the main ingredient in the gas that we burn in our lab. And oxygen. Most people would think that oxygen is just O. But if you took a look at the notes, there is a section in the notes. Let me see if I can find it for you real quick. It's Roman numeral 1, letter C, number 2B. It says the diatomic 7. There are 7 elements on the periodic table that are never found by themselves. They're always what we call diatomic, and oxygen happens to be one of those. So we never really find oxygen just as itself. It is diatomic, which means there's going to be 2 of them. Okay. So now we have each of our 4 chemicals turned into a formula. Now what we have to do is take these and turn them into symbols. Okay. So this is also in the notes. There was a whole list of things. So this is Roman numeral D, or Roman numeral 1, letter D. 2B says symbols found in equations. It gives a whole list of things. These are some very commonly used ones. But what we're interested in is when we put 2 chemicals together, this plus is actually going to turn into a plus sign. And means the same thing as that. So we do have to worry about a few things. So plus turns into a plus sign, and turns into a plus sign. And this yields. This is a special thing in chemistry. This is where the magic occurs. We get an arrow sign. So we've taken all of these. We've got all of our chemicals, all of the words turned into symbols. Now, if we took time and erased and someone had to write the sentence and someone wrote the symbols, I can bet you imagine that the symbol form or our formula equation is going to be much faster to write. Okay. Also, it gives us a great idea as to what elements are there and how many we have. Okay. So that's the example that's out of our notes. Let's do one that looks a little bit scarier, just for fun. Okay. So we've got this one. We've got some sodium chloride, and lead 2 nitrate makes sodium nitrate and lead 2 chloride. Same thing, right? But we do have to go through and find our chemicals. So we have one there. I know we have a stop because we have an and, so we have a brand new chemical. Now I have this word makes. Last time I used the word yields produces, anything like that, that's where our arrow is going to go. Sodium nitrate and lead 2 chloride. So we have to turn each of these into this. So this is where we're going to have to break out that ion sheet. Okay, I know that sodium is Na and it wants to be a positive 1. Chloride is a Cl and it wants to be a negative 1. We can look these up right off of our ion list. Lead is Pb. There are 2 types of lead. We have lead 2 and lead 4. This one says 2, so that means that's a positive 2. Nitrate off our list is an NO3 with a negative 1. Sodium, once again, Na positive 1. Nitrate, NO3 negative 1. Lead 2 is a positive 2. Chloride is a negative 1. At this point, it's been a long time since we've done it now, but this is where we're going to use any of those 4 methods that I taught you in order to turn these into formulas. Most of you remember doing the crisscross method, where we ignore the sign. We reduce these numbers. This is 1 and 1. It can't be reduced anymore. And then we crisscross. So sodium chloride turns into Na, one of them, Cl, one of them. So sodium chloride is NaCl. We've got our word and, so I'm going to use my plus sign. Lead 2 nitrate, Pb positive 2 with NO3 negative 1. Right? So we ignore the signs. We try to reduce 1 and 2. That's as far down as we can go. We then crisscross. That 2 goes here. That 1 goes there. So I have 1 Pb, and I have 2 NO3s. I don't want this to look like 32, so NO3 has to go inside. Remember, that's polyatomic. The 2 goes on the outside. Makes, that's going to be our arrow. Sodium nitrate, there's a 1 and 1, so I only need 1 of each after I crisscross. Because I'm only using 1 NO3, I don't need parentheses there. And lead 2 chloride, so Pb with a positive 2. That 2 goes there, that 1 goes there. We should get PbCl2. So that's taking that word equation, sodium chloride and lead 2 nitrate, make sodium nitrate and lead 2 chloride, into our formula equation. NaCl plus PbNO3 in parentheses 2 yields NaNO3 plus PbCl2. Same information, just in a much shorter, quicker to write, easier to see method, right? However, if we have lead 2 nitrate, it must be that formula. Right? If we just put PbNO3, or let's say we used lead 4, which would give us a PbNO3 4, if we used either of these 2 formulas, that would not represent what we see up here. Right? And what happens here has to be represented here. So this is very tricky because our formulas do have to be correct in order to make this work. Either of these 2 formulas would make that incorrect.